In this lesson, we will go through an example of balancing a redox reaction equation. Here is our redox reaction equation to balance, and we can see that it takes place in an acidic solution. Let's take a look at our steps to see how to begin balancing. Our first step is to determine what's oxidized and what's reduced, then split our reaction into two half reactions. To figure out which species is reduced and which is oxidized, we must assign oxidation states. Starting with our first molecule, we know from our rule of oxidation states that oxygen must have an oxidation state of -2. If we have 3 oxygens, each with an oxidation state of -2, then to have our oxidation states add up to the overall charge of -1 on the nitrate molecule, nitrogen must have a charge of +5. Now onto cadmium, which is in its elemental form, so it has an oxidation state of 0. Our cadmium ion, on the other hand, will have an oxidation state of +2 due to its +2 charge. In our final molecule, once again, we know the oxygen must have an oxidation state of -2. This time, since there's only one oxygen and our molecule has an overall charge of 0, nitrogen must have an oxidation state of +2. Now, comparing the nitrogens, we can see the oxidation state has decreased in the reaction, meaning nitrogen has gained electrons and thus has been reduced. Cadmium, on the other hand, has increased in oxidation state, meaning it has lost electrons and thus been oxidized. We can now break our reaction down. The oxidation process involves a cadmium atom transforming into a cadmium ion. The reduction process involves nitrate transforming into a nitric oxide molecule. So step 1 is now done. On to step 2, balancing our elements other than oxygen and hydrogen. Our only elements other than oxygen and hydrogen are cadmium and nitrogen. Both these atoms are already balanced, so nothing needs to be done. On to step 3, balancing the oxygens. Our oxidation reaction has no oxygens, so we can leave that as is. In our reduction reaction, however, there are 3 oxygens on the reactant side and only 1 on the product side. Thus, we must add 2 H2Os on the product side to give us 3 oxygens on both sides. Step 3 done. Now on to balancing the hydrogens. Since our reaction is in an acidic solution, we will balance the hydrogens by adding protons. Once again, there are no hydrogens in our oxidation reaction, so we can leave that as is. In our reduction reaction, there are no hydrogens on the reactant side, but 4 hydrogens on the product side. Thus, we must add 4 protons on the left side to balance out our hydrogens. Now we can balance the charges in our reaction equations. In our oxidation equation, the overall charge on the left side is 0, while the overall charge on the right side is +2. Thus, we must add 2 electrons on the right side to balance them out, giving an overall charge of 0 on both sides. In our reduction equation, the overall charge on the left side is +3 due to the -1 charge from the nitrate plus 4 +1 charges from 4 protons. The right side, on the other hand, has an overall charge of 0. Thus, we must add 3 electrons to the left side to balance it out. Step 5 is done. On to the final step. We must add the 2 half reactions, making sure the electrons cancel out as well as any common terms. Taking a look at our 2 equations, we can see there are 2 electrons on the right side of the oxidation reaction and 3 electrons on the left side of the reduction equation. So before we add these 2 equations, we need to adjust them so that there's an equal number of electrons in both. The lowest common multiple of 2 and 3 is 6. Thus, we can alter both equations to have 6 electrons in both. To do that, we'll have to multiply our oxidation reaction by 3 and multiply our reduction equation by 2. This gives us an oxidation reaction with 3 cadmiums transforming into 3 cadmium ions and 6 electrons. Our reduction reaction, on the other hand, is now 2 nitrates and 8 protons consuming 6 electrons to produce 2 nitric oxide molecules and 4 H2O molecules. Our electrons now cancel out, and we get an overall reaction equation with 3 cadmiums plus 2 nitrates and 8 protons, producing 3 cadmium ions, 2 nitric oxide molecules, and 4 H2O molecules. This is our final balanced reaction equation.